Here we are today, and we're going to be talking about vectors. This is graphical addition. This is just the first part of vectors. This is how we actually take a ruler and a protractor and we add them together and we find out what vectors are. If you want to check out a textbook, you can do that. This corresponds to page 110 through 112 in your textbook. Now, vectors have two parts. So every vector quantity has two parts. They have the magnitude, which is the size, and it has the direction. It's very important that we have two things. It's very important that you have both of those things, the magnitude and direction. We've talked somewhat about vectors before, things like velocity, acceleration, force, which you will see a lot in this unit. Force is measured in newtons, and those are vector quantities that we use quite frequently. So just as an overview, vector quantities can be represented by an arrow-tipped line. So we use the length of the line to indicate the magnitude and the direction that is orientated on the piece of paper to indicate the direction. The length of the line is always drawn to scale, and that represents the magnitude. 4 centimeters here would equal 4 kilometers. You always make up your own scale. Make it appropriate so it's big enough to see, but not so large that you run out of paper. Direction. The direction of the arrow represents the direction. So for instance, here we have due north. We have an arrow here that's due south, due east, and due west. Okay, those are the pretty easy ones. We'll be working with the standard compass rose, the north, east, south, and west compass rose, and this is kind of how we orientate ourselves around that. But sometimes the directions aren't due north, due south, east, or west. So to indicate that, we take and we use this system as it's illustrated here. Now if you've watched the vodcast dealing with protractors and how to use protractors, this should have already been explained to you. But as a quick overview, this angle here would indicate 35 degrees north of east. I like to take my angle and then I make my triangle. Okay, so my triangle would be like right here. That vector can be broken down into its components, its northerly component and its easterly component. And what I do then is I take and I look, well, which of these legs for the triangle, this would be a right triangle, lines up with one of the directions on the compass rose, and in this case it's east. Okay, so it lines up east of that, so that's going to be listed second. That's my second direction. North here is my first direction because I'm actually north of the east axis, so I'm north of that, so this tells me I'm 35 degrees north of east. Now you could also describe this angle on this side instead, and that would still be describing the same line. In that case, this would be, what's 90 minus 35? 55. So this would be 55 degrees. And then you just switch it around, and it's east of north. And you can see we've gone east of the northerly direction. So 55 degrees east of north would also be an acceptable way to describe this line. Over here in this example, we have 12 degrees south of east, and it's obvious that this is not drawn to scale. These are just kind of random numbers that I put in here to give you some examples. So now, when we take and we add vectors, what you're going to do is you're going to take and tie the tip of one vector to the tail of the other. And when I'm talking about vectors, if we have an arrow, you think of this part right here as the tip. Put this in your notes. And this part down here, without the arrowhead, that's called the tail. Now it is very, very, very important to make sure that you put arrowheads on your arrows. Okay? These are a must. It indicates the direction. Remember, we're dealing with vectors. Those have two parts, magnitude and direction. So we take the tip of one vector and we tie it to the tail of the other. The sum of those two vectors is called the resultant. If you look at this diagram down here, we take vector 1, which was in the easterly direction, and we tied it to vector 2 in the northerly direction. Okay, so vector 1 is tied tip to tail, right? And then vector 2. Now the resultant starts at the tail of vector 1 and it connects to the tip of vector 2. So wherever the resultant meets vector 1, you're going to have two tails together. Now, what's another name for a resultant in this type of a situation? Not always, but in this type of a situation, we have a right triangle. Okay, this is the right triangle. This would be one side, this would be another side, and then this here is also called the hypotenuse. Okay, so that's something that you can also think of the resultant as being the hypotenuse, at least in these first vectors that we're going to be doing, because they will be right triangles. Okay. So vector 1 plus vector 2 is going to be equal to the resultant. Now sometimes we have parallel vectors. If they are parallel and they're going in the same direction, you can add the vectors together, but if they're going in opposite directions, they would be subtracted. So for example here, we have a person who's walking 4 blocks due north. He then stops, pauses, chats for a little bit, and then walks 2 more blocks due north. The resultant, if we take our two vectors and we add them tip to tail, we're going to get 6 blocks due north. 6 blocks due north. Now, what happens if we were going 4 blocks north, but then we stopped and paused, and we went 2 blocks south? Okay. Well, how would we do that? We would take our 2, we'd tie tip to tail. Okay. That would be 2. Our resultant then is going to be this portion here, and it would be 2 blocks. Okay, so you just take and you subtract the 2 because they were parallel to each other, but they weren't going the same direction this time. This time they were going 2 opposite directions. So if they're going the same direction, you add them. If they're going opposite directions, you subtract them. Now, let's go ahead and try a practice problem. Let's say we take and we graphically add a 45 Newton vector pointing due north to a 30 Newton vector pointing due east. We're going to find the magnitude and the direction of the resulting vector. So first what I'm going to do is I'm just going to kind of sketch these out before I get out my ruler or my protractor and do everything to scale, just so I can get a rough estimate of what I'm supposed to be doing. So I need to take a 45 Newton vector pointing due north. So this would be my 45 Newton vector. And realize that capital N is the abbreviation for the Newton. So the Newton is a capital N, and it's a unit of force. And later in the year, we'll do a full unit on forces and friction and things like that. But for now, just know it's a unit of force. Remember, a force is a push or a pull. And so when you see that, don't get confused and think that that means north, because it actually here is meaning newtons. Let's take then and we add that to a vector, a 30 newton vector pointing due east. So this is 30 newtons due east. And I need to find the magnitude and direction of the resulting vector. So if I take and I add these two together, I can add them in two different ways. Remember that I need to put the tip to the tail. So I could take and I could simply add them together in this fashion, with this being my 30 newton vector and this being my 45 newton vector. And then my resultant would be right here. Or another way I could do this is I could take and put my 30 newton vector here and then tie the tip of that to the tail of my 45 newton vector, and I'm going to get the same resultant. Alright, so to do that graphically, I'm going to switch camera views here and switch over to the way that you do this using a protractor and a ruler.
Mommy, a book.
What?
A book.